So what will you factor out from all three?
3x.
3x indeed. Careful, we started with 3 terms. You must give me 3 terms in parentheses. No term can go away. Why? Because when I distribute 3a, I have to have 3 terms to recover the original polynomial. So please give me 3 terms inside. Do not simplify just yet. Of course, the problem should say here, m not equal 0, x not equal 0. Otherwise, the whole thing collapses.
X to the 5th minus 6x to the 4th minus 20.
That's it. Let's check. 3x times x to the 5th, yes, that's correct. 3x times negative 6x to the 4th, yes, that's correct. 3x times negative 20, yes, that's correct. At this point, I am allowed to simplify because I will simplify only factors. X from the top with x from the bottom. 3 from the top with a 3 from the bottom. This time, there is still a fraction. So I have to rewrite it as x to the 5th minus 6x to the 4th minus 20 divided by 5. Do not attempt to simplify 5 with 20 or whatever else. It's not possible. This is it. Of course, the correct answer is divided by 5 only if x is not 0. Otherwise, the whole thing does not exist anymore.
Will we ever see it where x is 0?
No, not in this class. But you have to state restrictions. You have to get used to it. The book does not emphasize that, and I completely disagree with that. See, when I ask you how much is 2 over 2, you will say 1. You will never say only if 2 does not equal 0. Of course 2 will never be 0. There is no point in writing this. But x over x is not 1 unless x is not 0. This is the correct answer. X over x is 1, assuming that x is not 0. Otherwise, it will not be 1. Because 0 over 0 is an indeterminate case. Okay, moving on. Do we need to work on 4? Do we need to work on 5? Do we need to work on 6? I think we should work on 6. So let's work on 6. 9m to the 4th minus 4m to the 7th plus 2m to the 6th over 20m to the 4th. Notice that you cannot do anything at the top. This is it. The numerator cannot be touched. Now we have option 1 and we have option 2. Which option would you like to work on this one with? Option 2. Very good. We can work on option 2 first, and then we can use the option 1 and separate it. It doesn't matter. After it's simplified, we can separate it, or we can separate it and then simplify. It's the same thing. So what would you factor out? 9, 4, and 2 have no common factors. So you can only factor out some power of 4. Which power?
To the 4th.
Yes, it has to be the smallest. I have 3 terms originally. I have to have 3 terms left in parentheses. such that when I distribute them back, I recover those. Because I can't change the problem. So, anyone?
9 minus 4m to the third plus 2m to the second.
That's it. The only thing I can cancel out is 4 of those and 4 of those. Now I can separate it. I can still separate it. 9 over 20 minus 4 over 20 m to the third plus 2 over 20 m squared. And simplify these fractions. So I have 9 over 20 minus 1 over 5 m cubed plus 1 over 10 m squared. I don't like it because it's not arranged in descending order. So I can arrange it now. Negative 1/5 m to the third plus 1/10 m squared plus 9 divided by 20. No one can further simplify this in any way. Any questions? Okay, let's see 7. Find the quotient, which is what we just did. Write it as a fraction and then factor or simplify or separate. Same thing. Let me know if you want us to. You can separate or you can factor out. In these sophisticated or, large numbers, I would separate. I would not waste my time to factor, just in these cases. Okay, so let's take a look at number 9. Do we want to work on number 9?
Yes, please.
Very good. In number 9 we have 2x cubed, 2x plus 3 minus 7x squared, 2x minus 6. Everything divided by 2x squared. The numerator is not factored. We still have 2 terms. Don't touch anything. So we have this term and we have this term. These are not factors. You cannot simplify with the denominator in any way, shape, or form. First option for this problem is number 1, distribute. Number 2, combine like terms. And number 3, decide how to simplify. So let's work on this problem for a minute on our own. See what we can do. Can anyone give us the intermediate step after distributing? No calculations, just the distributive piece. To be honest, I would have factored and not distributed first. I would have factored out x squared, but it's okay for now. Let's distribute first.
Would it be 4x
to
to
the,
the third?
yes, plus
6x
to the
to the
third,
third, I'm sorry.
yep, minus
14x
to the third,
third.
plus 42x
Yeah,
squared.
x squared.
Good. Do not attempt to simplify anything yet. But now we have to combine like terms because we can. So we have 4x to the fourth, and I have to combine 6x to the third with minus 14x to the third. What do we get? Minus 8x cubed plus 42x squared. Is this clear? So far. Is this okay so far? Yes, no, maybe.
Yes.
Okay. So now let's factor the greatest common factor in the numerator.
Just 2x squared.
2x squared. We started with 3 terms. I better have 3 terms in parentheses, otherwise I will never recover these.
Let's see, 2x to the second
Yes?
minus 4x to the x.
Yep.
Plus
Plus
21x. Just 21.
21. Good.
Yeah.
Nice. Very nice. Gone. Gone. So the simplified form this time is not a fraction. It's just 2x squared minus 4x plus 2.
21.
21, yes, sorry. Thank you, thank you. I wasn't trying to see whether anybody's paying attention. No. I was just in my head was no excuse. I was moving on to the next problem. Good. Any questions on this? Okay. Okay, they're giving us puzzles again. Oh my goodness. Okay, puzzles. If you want to work on any of the puzzles, please let me know. What polynomial, when divided by 9y squared, yields this as a quotient? Okay, let's work on one of them. So let's say 14. So what polynomial divided by 9y squared gives us y squared minus 6y plus 5? This is a trivial question if you remember what we talked about. Exactly. All you have to do is cross multiply. It's a proportion. You can always put everything over 1. So this polynomial, I'm going to call it P of y. P of y is this times this, 9y to the fourth, minus this times this, 54y to the third, this times this, plus 45y squared. Proportions, proportions, proportions. Please keep those in mind. Okay, yes, they're giving us more puzzles. Okay, so we're given the area. Let's work on this one. 16. Any questions before we continue to 16, please? So they're giving us the area. So the area is 2x squared plus 8x. In squared inches, of course, and its length is 2x. The length is 2x. Find its width. Good. So we know that the area is length times width. I replace the area by 2x squared plus 8x. I replace the length by 2x. and I'm asked to find the width. What should I do to both sides of this equation to find W?
Divide by 2x.
Exactly. 2x squared divided by 2x is simply x. 8x divided by 2x is simply 4. It takes a blink to check. I will put this in here, distribute 2x, and see if I recover the left-hand side. If I don't, this is wrong. 2x times x, copy the base, add the exponents. 2x times 4 is 8x. So this is the width. Okay? I think we can consider this done, I hope. 17. Okay, the volume, let's work on the volume, and let's see what 18 is saying. Okay, so let's work on 17 and 18. So, the volume of a box is 8x to the third plus 72x squared. The area of its bottom is 8x squared. The area. Find the height in terms of x. Okay. So remember, the volume is base times height times width. Or I should say maybe better length times height times width, or length times width times height. I want that better. Now, the length times the width is the base area, which in the problem is given to us at 8x squared. So this piece is 8x squared. This piece is given to us at 8x cubed plus 72x squared. This is what we have to find. So allow me to erase this, just I don't want to confuse you. Hopefully you're looking at this. That's my wish, my hope. Okay. So let's write the equation. Here's the equation. 8x cubed plus 72x squared equals 8x squared times the height. Like before, in the previous example, all we have to do is divide both sides by
8x squared.
Yes. So 8x cubed divided by 8x squared is just x. 72x squared divided by 8x squared is just 9. And it's done. If you want to check, plug it back in. 8x squared times x, 8 times x is 8x cubed. 8x squared times 9 is 72x squared. And the last problem, number 18. Let's see what 18 is asking us to do. Again. So here, the average cost of manufacturing X computers per day is given by the expression below. I'm going to copy it. 0.004x cubed minus 0.9x squared plus the 170x plus 15,000. Everything divided by x. Simplify the quotient by dividing each term in the numerator by the denominator, and then use the result to determine the average cost when x is 190. X is 190 units per day. Good. So first let's simplify. So in order to simplify, we will separate. We are going to use option 1. So we're going to separate. When I separate this by this over this, I get 0.0404x squared. Because x to the third divided by x is x squared. Then this over this is negative 0.9x. plus this over this is 170. But this, the last one cannot be simplified, so it has to be left alone in a fraction form. Now, they want us to evaluate this when x is 190. Please do not do it by hand. Please put it in the graphing calculator under y equals. Clear whatever you have in there. And enter it as is. And look at it and make sure that it's entered correctly. That's the best. Minus 0.9 times x plus 170 and plus 15,000 divided by x. Look at it, make sure it's correct, and then all you have to do, it goes to second and table and plug in 190. That's all you need to do. So 222.35. So the answer, the cost is $222.35. This is the best way to punch it in and get the final answer. It's the average cost of X computers per day. That's the average. Say it again.
I didn't think to put that in the graphic calculator, so you keep that in mind.
Yes, I recorded this when we entered functions and evaluated them. The recording is there in the module, in the top module. Yes. Good. So I think now we are at the point where we can finally move on to 5.5. Let's look at the topics. So please complete everything in 5.4. It's a lot of work, but we went through everything, really. Multiply two binomials with using the FOIL method. This is nothing. We did the same thing. Multiply special products. I'm going to talk about the special products right now. This is very clear. We're going to look at examples in a moment. Good. So multiplying two binomials, again, as an example, x plus 2 times x minus 3. These are two binomials. I have to distribute x to these two terms and then 2 to these two terms. So x times x is x squared, x times negative 3, negative 3x, 2 times x, positive 2x, 2 times negative 3, negative 6. Nothing new, we've done this before. Now I have to combine like terms, x squared minus x minus 6. And this is it. What do we mean by special products? Special products are formulas that have to be memorized. Yes, you can keep them on your formula sheet, but that's not a good idea. At some point in time, the formula sheet will not be enough. You will need a 1-pound book to carry with you. So these special products have to be understood, memorized, so you don't stumble. Because if you say, oh, but I have them on the formula sheet, you're going to stumble later on. So here are 3 special products that we are going to look at. Let me see my time here. Okay,